Okay, so we are going to do a review of some grade 10 stuff over the next few days. Sorry, I'm just trying to get this off here. There we go. We're going to do a review of a few grade 10 concepts over the next few days. So today I want to take a look at foiling and factoring. These are skills that are going to be carried forward in your math travels for the rest of high school pretty much. So it's good that we review these regularly and that we have them down. So FOIL. FOIL stands for first, outside, inside, last. So let's try it out on this one. We're going to do the firsts multiplied together. So what's 3x times x? 3x squared. And then outsides, which are these guys. So 3x times negative 5. Negative 15x, good. Insides. And lasts. Negative 35. And then you're going to gather any like terms that you have here. Negative what? Positive 7 times negative 5. Okay, so make sure you keep the signs with those things that you're multiplying. Okay, and then, so we've just put something from factored form into standard form. If you remember your different forms of a quadratic from last year. So this is factored form. And this is standard form.
Wait, standard form is like the quadratic formula, right? Like a, b?
Yep. ax squared plus bx plus c. Yep. Oh, sorry. I put formula, standard form. Okay, so we're going to try out FOIL on something a little bit more complex. Can I scroll from this one?
What would be the middle one? Just like
this one we're just expanding out to get into standard form, so it's just a step along the way to get there. Okay, so when I see 3x minus 2 squared, it means 3x minus 2 times itself. So I write that thing twice. Okay, there's a couple routes that you might be able to take to get to an answer here. What I'm going to do is we're going to focus on foiling inside the brackets first, and then we will distribute the number out front into each term. Okay, I think that's probably the least confusing way. So 3x times 3x, I'm doing firsts. That's 9x squared. Outsides, it's negative 6. Insides, another negative 6. And lasts, it's positive 4. Okay, and then same thing over in your brackets here. You're going to do firsts, which will give us x squared. Outsides, negative 5x. Insides, negative x. And lasts, positive 5. Okay? Again, a couple of different ways that you can do this. I'm just going to simplify the x's inside the brackets here. We'll get negative 12x and negative 6x. And then we're going to distribute the values outside the bracket into every single term in here. So 18x squared minus 24x plus 8. And then, remember, we're multiplying here by negative 3. So negative 3x, negative and negative here make positive. So positive 18x. And then negative and positive here make negative 15. Okay, gather your things with common variables. Gather your constants together. What I mean by constants is numbers without variables. So just the numbers that are by themselves. So we're going to gather the x squareds together. 18x squared minus 3x squared is 15x squared. Gather your x's. get negative 6x, and gather your constants. Get negative 7. Okay, and now we're in expanded form.
I just have one question.
Yep, go for it.
I got everything, but for like the second line, the third line, 2 bracket 9x squared. How do you get those 2 minus 6x? Is that from 3 times 2?
So that would be from 3 times negative 2 and negative 2 times 3.
Oh, okay.
Yep.
And then the 4 will just use
The 4 is negative 2 times negative 2.
Alright.
Wait, this is jealous.
Yep.
Is standard form the same as expanded form?
Yep.
Okay.
Any other questions on this one? How did you get from this step to this step? Where did this number come from? Anything like that? If you could FOIL something like this, you're good with foiling for this class. Okay? All right, let's scroll. Common factoring. Okay, so what we want to find here is something common that we can divide out of every term. So every coefficient, and the largest that we can take out of a variable is the lowest exponent on that variable in all terms. So let's first take a look at 25 and 15. What is something I can divide out of both of these? 5. So remember, guys, when I take out a common factor, that thing doesn't just poof and disappear into thin air. It goes outside of a set of brackets. So we actually take that common factor out and we put it outside a set of brackets. And let's look at the variable part. What is the most k's I can take out of 6k's and 4k's? Not divisible. I can take out, so if I have 6k's and I have 4k's, I can take out 4, maximum of 4 from each. So I can take out k to the 4. So we're going to divide each term by 5k to the 4. And we write what's left in the bracket. So 25 divided by 5 is 5. If I have 6k's and I take out 4 of them, what's left? 2 of them, so k squared. And I took out all 4k's in the last term, so those are gone now. They're out front. And 15 divided by 5? Okay, so this will be plus 3 in here. So that is fully common factored. I will know this is fully common factored if I look in the brackets and there's nothing left that would be common between those two things. So 5 and 3, I can't divide any further except by 1. And then there's no k's in the second term here, so I can't really take out any more k's. That's how I know that I've gotten the furthest I can go. How can you check your answer for stuff like this? Yeah, if I distribute this back in, I should get back what I started with, right? Okay, let's look at the next one. 21, 28, and 7. Is there something I can divide out of all of those? 7? Okay. What's the maximum number of c's that I can take out from every term?
1.
It will always be the one with the lowest, so there's only 1 in the third term, so I can only take out 1. And maximum amount of d's? Yes, we can take out 3. So you're going to divide each term by 7cd cubed. Okay, so 21 divided by 7 leaves us with 3. I had 4 c's and I took out 1. So I have 3 left. I had 3 d's and I took out 3, so there's no d's left. Negative 28 divided by 7 is negative 4. I have 2 c's in that second term and I took out 1. So there's 1 c left. I had 5 d's in the second term and I took out 3. So there's 2 left, a d squared. And what's 7cd cubed divided by itself? 1. Good. I didn't hear any zeros that time, so that was good. Usually I hear that the last term is now 0. Did you? Yeah. I didn't hear them at least, so you're safe. Okay, any questions on those two? Okay, let's move forward. Uh-oh. All right, factoring by grouping. So I want us to think about the first group and the second group here. Do you guys see anything common between these two groups?
Yes.
They both have the same.
X minus 5.
They both have an x minus 5. So if I take out an x minus 5, that's my common factor that I'm taking out. I always open a set of brackets to write what's left. And I divide each of these by x minus 5. So what will be left in my second set of brackets here? Right, these will all cancel, and I will have 3x minus 2 in the second bracket. I don't need to see that. I just want to make sure that your memory is refreshed on some of this stuff. Okay? That's the reason why it works, is basically. So in a case like this, where you have 4 terms, we can also factor by grouping, but it's going to take a little bit more to get to something that looks like this. So we're going to think about the first group as if it's the first 2 terms and the second group as the last 2 terms, and we're going to common factor something from each. So just looking at these first 2 terms here, I can take out a 2 from both of those, and also an x from both of those. So what would be left here? So the 2 is gone, so an x and a 2. Perfect. And then what's common in the second set of terms? A negative 1, yeah. So we'll take that out, and we're left with a positive x and a positive 2. Okay, now we have something that looks just like this. We can take out the common x plus 2's. And when we common factor, technically that means we're dividing that out from each term, right? So we always open up a set of brackets here and write what remains, which will be 2x minus 1. So that's our final answer. Okay, now this is in factored form. Okay, both of these are in factored form. Any questions on those ones? Josh? Good question. Does anyone have the answer to that? What does factored form tell us about the graph of a quadratic? No one remembers? Like, what does this tell us? Zach?
Tell us, I think, the vertex. Let's open the parabola.
That would be vertex form, right? So factored form. Sheila? There's no slope for a quadratic. What x values? There's special x values.
I know what the concept is. I just forget. What's the question?
The zeros.
Yeah, x-intercepts. So I would know that one of my x-intercepts is at 5. And for this one, it would be like 2 over 3. So yeah, factored form tells us where the graph intersects the x-axis. Okay. Factoring. Fun fact, I just taught my calculus class, again, how to factor the other day. So, grade 10. All right, so we are looking for 2 things that multiply to 56 and add to the b value, which is negative 15. If you remember, this is ax squared plus bx plus c.
9 and negative 9 and negative 6.
I think that's 54, is it not? 9 times 6?
Yeah. 9, 5 and
Negative 8 and negative 7. Good. So when your a value can be common factored out to leave your x squared with a coefficient of 1, you can just find your numbers and put them in brackets right away. Okay, this is like easy trinomial, we just put them right in the brackets, and then we know the x-intercepts of this function are at 8, 0, and 7, 0. Okay, that's what factored form tells us. Okay, multiplies to the c value, which is 6, and adds to -5.
-2 and -3.
That works. And again, the x squared has a coefficient of 1, so it's just x minus 2, x minus 3. Okay, x-intercepts here would be 2 and 3. Okay, something like this, we can't easy factor in the form that it's in here. The big thing here is that we always want a common factor first, because it makes our life 20 times easier if we can happen to common factor and then maybe do like easy trinomial factoring instead of doing 2 times 42 in that whole process. So this has a common factor of 2 in each term here. And then I can actually just factor the trinomial that's left inside there. So I can actually find two things that multiply to -21 and add to -4.
7 and 3, -3.
Close? 3 and -7 works. Okay, so keep your 2 out front, and then it would be x plus 3, x minus 7. Okay, so here the x-intercepts are -3 and +7. Okay, so this is super important because it can make your life much easier. You always want a common factor first. Any questions on those 3 that we just did there? Okay. Psst. Psst. Thank you. Okay. When your a value can't be common factored out, still check for a common factor. If you find that you can't common factor anything, we need to do a bit of a longer process. Just deciding the way I want to show you guys how to do this. There are many, many, many different ways that people factor trinomials where a is not one. You may have been taught something different than someone else. I'll teach you guys a little method that I like. There's like tons of different ways to do this. But we are going to find two things that multiply to a times c, which in this case I believe is -120. Okay, 8 times -15. And they add to the b value. So we need to find two numbers that add to 2 and multiply to -120.
What is that symbol underneath that? Is that plus? Is it plus 2?
Adds to 2, yeah.
Yeah.
-10 and +12. Perfect. And then we will take the a value and we're going to put it underneath each of these functions. Okay, this is just kind of like a little trick method that I like. And we will reduce. Okay, I'll show you guys the way that maybe many of you were taught in grade 10 after this. So how do I reduce 12 over 8? What does that reduce to? So 4 goes into both of those, so 3 over 2. And how about -10 over 8?
5 over 4.
-5 over 4. Okay, so you guys just found your two sets of brackets. So this is going to factor into our two brackets. The first one will be 4x minus 5. And the second one will be 2x plus 3. Okay, so certainly you can use that method. I will show you guys maybe the method that most of you guys were taught, which is very similar to kind of what we did up here. But you can feel free to use this method if you feel comfortable with that. I will post a video for you guys as well that shows like some of these methods, and if you feel like you want to watch that just to decide on which one you like, you can do that. So probably how a lot of you guys were taught was that we have to do still the a times c, so we need to find two things that multiply to 36 and add to 13, which is essentially what we did here. So two numbers, they multiply to 36, add to 13.
9 and 4. Isn't it basically the same thing where you're just putting it in the x?
No, you can't, like the same thing as this, you mean?
No, the x.
I'm not sure. Yeah, but I'm going to show you a different method like with the work here. Okay, so 9 and 4. So that's basically this part of what we did. J-Deep is right. That's still what we did before. And then probably how a lot of you guys were taught was you take this term and you're going to split it up into 9x and 4x. So it'll be plus 9x plus 4x plus 3.
And then we turn it into FOIL. Right?
And then we do the grouping that we did above.
Yeah.
So we do group 1, group 2, and we common factor from each. So in the first group, we take out a 3x. We're left with 4x plus 3. Second group, we can't really take anything out other than a positive 1. And then we're left with 4x plus 3. And then you're going to remove the common bracket between these two, which is 4x plus 3. And you will be left with 3x plus 1. Okay? So if you would like to do it that way, you can do it like that. You can do it like this way if you want. It's up to you guys. But this is probably maybe the most familiar way that many of you were taught. Yep. Okay, any questions on that one? No? We're good? Okay. Moving forward. Okay, I'm just going to show you guys a couple special types of quadratics that we have patterns that we can quick factor. One of them is difference of squares. Difference of squares need to have 3 things in order to be able to quick factor into the difference of squares pattern. The first one is that out of ax squared plus bx plus c, you actually won't see the bx term if it's a difference of squares. The second thing is it needs to be a difference. Okay, it's called difference of squares. Difference means subtraction. You need to see a subtraction sign between your two terms. And then the last part is that each term needs to be able to be square rooted and give you out a whole number. Okay, we call these perfect squares. So something that's a perfect square is like 9 because I can square root it and get 3. Another perfect square is 25 because I can square root it and get 5. Other perfect squares? 36. 100. 49. 64. Yep. 121. Okay, perfect. 16. Yeah, awesome. Okay, so that's great. Okay, so for each of these, notice that we're missing that bx term. So there's no bx term in the middle of these guys. They are all subtraction in between the two terms. And I can square root the first term and get x. And I can square root the second term and get 10. These values are what's going to go into my brackets. So with difference of squares, if you guys remember this, you get one positive bracket, one minus, and then you do the square roots of the first and last term here. So x plus 10, x minus 10. Okay, so if you notice a difference of squares, you can do that quick pattern. Certainly, we can also say what two terms multiply to 0 and add to negative 100. It would be positive 10 and negative 10, and then factor. Okay, can someone factor the next one for us? So 1 will be plus, 1 will be minus.
2x
Rose, go ahead. Perfect. Okay, so the square roots of each of those. Square root and square root. Okay, 1 plus, 1 minus. Okay, next one. Someone want to factor this for us? Perfect. So 1 plus, 1 minus. Square root of 25x squared is 5x. Square root of 36 is 6. Done. Okay, those ones are super nice to be able to recognize the difference of squares pattern because I don't really want to factor something like this, right? This one's not too bad if I factor it with the regular method, but 4x squared minus 49, I would like to just do that as quickly as possible. Okay, any questions on those guys? Okay, last one, perfect square trinomials. So perfect square trinomials, they will look, so they are trinomials, tri meaning 3, nomial meaning term. So you'll see 3 terms. The trinomial pattern, if you can notice it, you can actually factor really quickly. You can certainly factor with this method that we did above. Okay, so that's always possible. But if you happen to notice the perfect square trinomial pattern, it's actually super helpful. So you will notice a perfect square trinomial if your first and last terms are perfect squares, just like in difference of squares. And then the middle term will be 2 times the square roots of the first and last. So we'll just test it with this guy. So can I square root 4x squared and get a whole number?
Yes. Yes.
So I get 2x. Can I square root 49 and get a whole number?
Yes.
Yes. And does the middle term equal 2 times those roots from above?
Yes. Yes.
28x. So yes, it does. So this is a perfect square trinomial. So perfect square trinomials, unlike difference of squares, with difference of squares we get 1 plus and 1 minus. With a perfect square trinomial, we'll get 2 brackets that are the exact same, and they will share the sign of the middle term. So whatever that middle term is will be the sign in here. So they can either be both plus or both minus. And then we put in the square root of the first and square root of the last. So I'm going to put in 2x in for the first one, square root of the first, and then square root of the last term. Okay, so kind of similar to difference of squares, but a little bit more tricky to identify because they look like regular trinomials. And then we just rate it as 2x plus 7 squared. Okay, so for the next one, you're going to check if the first and last terms are perfect squares. So can I square root 25x squared and get a whole number?
Yeah.
Yes, we get 5x. And can I square root 36 and get a whole number? Yes, I can. And is the middle term equal to 2 times those square roots?
Yes.
It is equal to 60x, yes. Okay, the negative just tells us what sign goes in the brackets. So I'm going to get 2 brackets. So like difference of squares, but both of them are going to match the term in front of the middle term. So minus and minus. And then you're going to stick these square roots into the brackets. So 5x and 5x, and then 6 and 6. Okay, and then you're just going to simplify this to 5x minus 6 squared. Okay, if you factored like the long way by finding like a times c and finding the middle, what adds to the middle term, you can still get to these answers for sure. But these ones are just like, it can be helpful if you can recognize the pattern because then you can factor it more quickly. Josh?
On test, would you be different
I won't be too picky about perfect square trinomials, but for sure, like difference of squares, you should be able to identify those, right? Because they're the 2-term expressions. So I think you should be able to see those ones. Okay, perfect square trinomials, like when we do completing the square, which you guys learned in grade 10, it's important to understand how to factor these guys. So I'm going to be using perfect square trinomials tomorrow. Okay, any questions for these guys? No? Okay, we've got 20 minutes, so you guys can do some factoring practice. Let me just stop this here. Sorry. That was by one of my grade 9s last semester.